In today's lesson, I'm going to do a few questions on conditional identities involving the angles of a triangle. But before I do, I quickly want to recap few formulas which we will need it during these examples. So the first one is cos 2 theta, which is also equal to cos square theta minus sin square theta, which is also equal to 1 minus 2 sin square theta or 2 cos square theta minus 1. Sin A plus sin B is equal to 2 sin A plus B over 2 cos A minus B over 2. Sin A minus sin B is 2 sin A minus B over 2 and cos A plus B over 2. Then cos A plus cos B is equal to 2 cos A plus B over 2 and cos A minus B over 2. So when it's cos A plus cos B, it's cos and cos. Cos A minus cos B is equal to negative 2 sin A plus B over 2 and sin A minus B over 2. Sin 2 theta is 2 sin theta cos 2 theta. So the first question I'm going to do is, if A plus B plus C is pi, show that sin 2A plus sin 2B plus sin 2C is equal to 4 sin A, sin B, sin C. So we are going to start with left hand side. So sin 2A plus sin 2B plus sin 2c, it doesn't matter. So we are going to start, you can pair up first and second or second and third, it doesn't matter. So I'm going to pair up first and second. And now as you can see, we have a formula for sin A plus sin B. Instead of A we have 2A, instead of B we have 2B. So according to the formula, this is equal to 2 sin A plus B. So instead of A I have 2A, so 2A plus 2B divided by 2, and then cos 2A minus 2B divided by 2, and then I'm going to copy sin C. Okay, so here this becomes 2 sin A plus B, and this becomes cos A minus B, sorry, this is sin 2C plus sin 2C. Now here I know A plus B plus C is equal to pi, which means A plus B is equal to pi minus C. So I'm going to replace this by pi minus C, cos A minus B. I also know sin 2C is 2 sin C cos C. So here this is sin 180 minus theta. So add sugar to coffee. Here we have theta. This is pi minus theta. This is pi plus theta. And this is equal to 2 pi minus theta or minus theta. And as we know, sin theta in second quadrant is positive. So this is 2 sin C cos A minus B plus 2 sin C cos C. Now from this I can take 2 sin C common, so I got here cos A minus B plus cos C. And now we are going to use the formula again for cos A minus B and cos C. But before we do that, we also know, as we know, A plus B is plus C is pi, so I can replace, because here we have A minus B, here I have C, but I can replace this C in terms of A and B. So this is 2 sin C cos A minus B plus cos pi minus, so I'm going to keep this C here and move A plus B there, and I'm going to use another bracket here, so pi minus A plus B here. Now this becomes 2 sin C, this is cos A minus B plus, now cos 180 minus theta, it's in second quadrant, and in second quadrant cos is negative, so which means this becomes minus cos A plus B. So now we simplified this too, so we got here cos A minus B minus cos A plus B. Now I'm again ready to use the formula here, so this is cos A minus cos B, and according to the formula this is negative 2 sin A plus B over 2 sin A minus B over 2. So 2 sin C and then negative 2, so this is cos A minus B, so this becomes sin. Now instead of A we have, this is our A and this is our B, so we are going to use, so first we add them, so A minus B plus A plus B divided by 2, and then I'm going to do the same thing, but now I have to subtract, so A minus B minus A minus B divided by 2. Okay, so when we subtract that, so now here this B and B get cancelled, and in this case your A and A get cancelled here. So I'm going to rewrite this on next page. So we got here, I'm going to rewrite this 2 sin C, and then we had in a bracket -2 sine a minus b plus a plus b divided by 2, and then I had sine a minus b minus a minus b divided by 2. And then I'm going to close this bracket again. So this I get here -4 sine c. Now, as I already explained it, this becomes sine a, and this becomes a and a got cancelled. So this is sine -b. Again, sine -b is going to be, so this is sine a. Sine of -theta, this is in the fourth quadrant and sine is negative there. So we will get one negative from here. So sine of -b is minus sine b. So that gives me positive here, and sine b. I'm going to write this in alphabetical order. So sine b, sine c. So we got 4 sine a, sine b, sine c, and sorry, this is what we were supposed to show that. So this is equal to 4 sine a, sine b, sine c, which is our right hand side. So this is our right hand side. Okay. Now let's move on to the second one. It's similar. So instead of sine, I have cos 2a plus cos 2b plus cos 2c, and I have to show this equal to -1, -4 cos a, cos b, cos c. So it's the same on parallel line. We start with left hand side, which is cos 2a plus cos 2b plus cos 2c. Now here cos a plus cos b, according to the formula, is equal to 2 cos a plus b divided by 2, and then you have cos a minus b divided by 2. Again, it doesn't matter. I paired up first and second. You can pair up second and third. It doesn't matter. Or you can pair up first and third, but then it's not very wise to do it. So it's better to do either first and second or second and third. So this becomes 2 cos a plus b and cos a minus b plus cos c. Now again, we know a plus b is equal to pi minus c. So this becomes 2 cos pi minus c cos a minus b plus cos c. Now this is equal to cos 180 minus theta is negative. So -2 cos c cos a minus b plus cos c, right? Now from here, we can see what is common here. So we have cos c common, which gives me here, if I take cos c common here, so I will get here -2 cos a minus 1 plus 1. Okay, so this is what I got here. But I have to show this is equal to -1 minus 4 cos a, cos b, cos c. So cos c is already here. But now we need to somehow show this, the remaining one. Now this is a bit tricky here. So if I took here from here cos c common, this is what I got here. So this is not helping me. So what I need to do in this case is, instead of from here to here, instead of taking this step, what I should have done here is, so we replace cos c. As we already know, cos 2 theta is equal to cos square theta minus sine square theta, or 1 minus 2 sine square theta, or 2 cos square theta minus 1. So I'm going to use, instead of cos c, there's no point for me to use cos square minus sine square then, because I will have sine square here. So it's better to use in terms of cos, and again for the same reason, I don't want to use 1 minus 2 sine square theta, then I will have a combination of cos and sine. So it's better to use this formula. So then cos c is going to be 2 cos square c minus 1. So I'm going to write here plus, so this step is not helping me. So I'm going to, from cos c, I'm going to write 2 cos square c minus 1. And now from this one and this one, 2 cos c, I can take 2 cos c common, or I can take -2 cos c. So let me take -2 cos c common. So I got cos a minus b minus cos C, and then I have negative 1 here. Okay. So now we need to replace this C, because I have here A minus B, here I have angle C. So I'm going to replace this C, negative 2 cos C, cos A minus B minus cos negative 1. Okay. So I'm going to replace this C by pi minus, again, A plus B. There is a reason why I'm not writing this as pi minus A minus B. I need this angle as in a bracket. So here I get here 2 cos C, and since I need negative 1, so I'm going to keep this negative 1. So always whenever you are doing this kind of questions, at some point you need to actually pause and see what we have to show, that what is the right hand side of the question. So, because when I was doing this, and then the problem in this step was that this was not taking me anywhere, right? Because I got +1 and then I don't know what to do up from this step. Whereas if I change cos C into 2 cos square C minus 1, then, sorry, this was cos 2C. So this is cos 2C, cos 2C, cos 2C, and cos 2C. So, okay, so that's why when I did this cos C, because I did not copy this correctly, and that's why this step is not the correct step. So please make sure that when you copy down the statement, that you are copying down the statement carefully. Since I did not copy it correctly, because I said it's cos C, and then I result into the wrong step. So cos 2C, cos 2C, cos 2C. That's why I needed to use one of the formulas for cos 2C, and the formula which I chose is this one. And I already explained this. So now I got this one, and then this becomes equal to, cos C is equal to pi minus A plus B. Okay. Now this becomes cos A minus B, and as we know, cos 180 minus theta is negative cos theta, so this becomes cos A plus B, and then negative 1. So negative 2 cos C. Now cos A plus cos B, the formula for cos A plus cos B is equal to 2 cos A plus B divided by 2, and then cos A minus B, so A minus B minus A minus B divided by 2, and I'm going to keep negative 1 here. So negative 1, negative 2 cos C. I got here 2 cos, this B and B get cancelled, so cos A, and now this got cancelled, so cos of negative B, but cos of negative theta, it is in the 4th quadrant, and that's positive, so negative 1 minus 2 cos A, sorry, 4, because 2 times 2 is 4, 4 cos A, cos B, and cos C. Okay, so this is how we show that these kind of conditional identities which involves, so condition in this case is A plus B plus C is equal to pi. I hope it is clear. So be careful, as I said, when you copy down the statement, make sure that you are copying down it correctly. Okay, so I'm going to move to the next example here. So if A plus B plus C is pi, we have to show that sine A plus sine B minus sine C is equal to 4 sine A over 2, sine B over 2, and cos C over 2. Now this question is different than the previous one. In the previous ones, as you know, that, or as you can see, that we had here the double the angle. So in these questions you had cos 2A, cos 2B, cos 2C. Whereas in this question I have this a single A, B, and C. So let's get started. So we know already the formula for, so I'm going to start with left hand side, sine A plus sine B minus sine C, and now I already know this is sine A plus sine B. This is equal to, the formula for sine A plus sine B is equal to 2 sine A plus B over 2, and then you have cos A minus B over 2. I'm going to decide later that what I'm going to do with this sine C. First, I would like to see what do I get here, okay? Now here, when you have sine A plus B over 2, let's use what is given here. So A plus B is equal to pi minus C, and then A plus B over 2 in this case will be pi over 2 minus C over 2. So let me see if I substitute, because this is the only step at this stage I can do, because I can't replace A minus B over 2. but I can replace a plus b over 2. So now sine 90 minus theta, it's in the first quadrant, it's positive. So, but sine 90 minus theta is equal to, so sine 90 minus theta is equal to cos theta. So this becomes 2 cos c over 2, and then I have cos a minus b over 2 minus sine c. Now I'm ready to use the formula sine 2 theta is equal to 2 sine theta cos theta, which means sine c is 2 sine c over 2 cos c over 2. So this becomes 2 cos c over 2 cos a minus b over 2 minus 2 sine c over 2 and cos c over 2. So here I can take 2 cos c over 2 common. So I got cos a minus b over 2 minus remaining is sine c over 2. Now let's have a look. So we already got this factor and 2 of that, and let's see what is the next step. Now I can't do anything about a minus b, but I can change c again using what is given. A plus b plus c is pi, so c is pi minus, again keep this angle together, so c over 2 is pi over 2 minus a plus b over 2. So this becomes 2 cos c over 2 cos a minus b over 2 minus sine, we will get here pi by 2 minus a plus b over 2. It's just too many brackets here, but we need that many brackets here. So we got cos a minus b over 2. Now again, sine 90 minus theta is cos theta, so minus cos a plus b divided by 2 and close the bracket. Okay. Now again here, this is cos a minus cos b. The formula for cos a minus cos b is equal to, we get here 2 cos c over 2, and cos a minus cos b is minus 2 sine a plus b, and then you have sine a minus b. So a minus b over 2 minus, now I have to use the bracket here. Okay, and now let's have a look. When we open it, minus 2 sine, this becomes a over 2 minus b over 2 plus a over 2 plus b over 2. Cancel, cancel. And then I have sine, this is in multiplication, sine a over 2 minus b over 2 minus a over 2 and then minus b over 2. And this get cancelled here. Okay, so we got here 2 cos c over 2 minus 2 sine. This is a over 2 plus a over 2 is a. And then here sine of minus b. But sine of minus b is in 4th quadrant, and in 4th quadrant sine is negative. So that's why we got here positive sine b. Sorry, this is a over 2. Oh, sorry, I forgot to do, because it's further, you need to divide, because it's the formula says divide by 2, which I forgot here. So this should be over 2 and b over 2. So we got our final answer for sine a over 2, sine b over 2, and then cos c over 2. Okay, so this is what we were supposed to show that. Okay, so the last example which I'm going to do here is, if a plus b plus c is pi, you have to show that cos a plus cos b minus cos c is 4 cos a over 2, cos b over 2, cos c over 2 minus 1. So again, let's start with left hand side. This is cos a plus cos b minus cos c. So I'm going to pair this up. Cos a plus cos b is equal to 2 cos a plus b over 2 and cos a minus b over 2 minus cos c. Okay, this time it is c. So okay, now again we replace a plus b over 2. So a plus b is equal to pi minus c. So a plus b over 2 is going to be pi over 2 minus c over 2. So 2 cos pi over 2 minus c over 2 cos a minus b over 2 minus cos c. Now this cos 90 minus theta is equal to sine theta. Okay, so this becomes 2 sine c over 2 cos a minus b over 2 minus cos c. So I did not do anything with cos c because I was waiting to see what will I get here, and that is the hint. So that should help me to decide what should I replace cos c by. So we already know cos 2 theta is equal to cos square theta minus sin square theta, 1 minus 2 sin square theta, and 2 cos square theta minus 1. So now, from here, I can see that I need to replace cos c by this one so that I can take sin c over 2 common. So 2 sin c over 2 cos a minus b over 2 minus, now I'm going to replace, since it's minus, I'm going to use another bracket, 1 minus 2 sine square c over 2. And now, this negative 1 we need, so I'm going to keep it at the end, and I'm going to open this again, cos a minus b over 2, negative 1, and this becomes plus 2 sine square c over 2. And now from here and here, as you can see, I can take 2 sine c over 2 common. So I got cos a minus b over 2 plus sine c over 2. I can't use the formula because it either has to be cos cos, sine sine, but here I have a mix of cos and sine, but again I have to use a plus b plus c is pi, which means c is pi minus a plus b. So c over 2 is going to be pi over 2 minus a plus b divided by 2. So I get here 2 sine c over 2 cos a minus b over 2. Now I'm going to do this step here. So sine c over 2 is sine pi over 2 minus a plus b over 2, which means this is equal to cos a plus b over 2. Same reason, sine 90 minus theta is cos theta. So I'm going to write down here cos a plus b over 2, and negative 1 we already have here. Okay, so this is plus here. So be careful, use more space. And now we are going to again use the formula here. So this is 2 sine c over 2, nothing to do with this. Cos a plus cos b is equal to 2 cos a plus b over 2. So a minus b over 2 plus a plus b over 2 divided by 2 this time. Be careful that there is a plus b divided by 2, and RA is this. So this is RA and this is RB, okay? And then we have cos a minus b. So a minus b over 2 minus, I am going to use bracket so that I don't make any mistake here. And then we have close bracket over here. And then we have negative 1, okay? So negative 1 I'm going to write down here, okay? Now here, when I open this, this is going to give me 2 sine c over 2 and then 2 cos. Again, this is a over 2, this is minus b over 2, so that's going to get cancelled. So that is a over 2, okay? Now here we have cos a over 2 minus a over 2 will get cancelled, and I will get here negative b over 2 and then negative 1. Okay, this negative 1 is outside this bracket. Now this gives me 2 sine c over 2, and cos of negative theta is cos theta, fourth quadrant. So 2 times 2 is 4. This is sine c over 2. And this one is cos a over 2 and then cos b over 2, and then you have minus 1. Okay, now let me check the statement one more time. Yeah, so according to the statement, this is sine c over 2, okay? So that was a mistake in the statement here. So this is cos a plus cos b minus cos c is 4 cos a over 2, cos b over 2, and sine c over 2 minus 1. And this is what I got here. So if I rearrange it according to alphabetical order, so I got exactly what was asked in the question. That's it for this video. I hope it was clear, and if you like my channel, please subscribe it and share it. Thank you.